Hello, we are Seba Lalani
And Joseph Carpenter.
from Alabama Industrial Assessment Center, and today we are going to talk about how our IAC analyzes air compressors. Air compressors are responsible for a significant portion of the total energy usage in industrial facilities. Therefore, investigating energy efficiency improvement opportunities in compressed air systems can help manufacturing plants to realize substantial energy and cost savings. An accurate evaluation of energy saving recommendations requires a good understanding of the baseline performance of the air compressors. To do so, we will be using three different softwares: HoboWare Pro, Log Tools, and Airmaster. First, we program the data loggers. To do so, we use a software called HoboWare Pro. Click on the Launch Device button at the top left corner of the window. This will bring this window where you can give the data logger a description and select size and type of the aim clamp used. We typically program the data logger to record the amperage drop for a week starting at midnight, with a recording interval of 1 second. This is done to understand the facility's weekly trend. To install the amp clamp, follow all facility safety procedures. Place the clamp around one of the electrical leads as shown. If possible, measure the compressor voltage as well. After recording the amperage draw, extract the data using HoboWare Pro. Click on the readout device as highlighted. After the data has been imported and saved, click on Plot to view the recorded data. HoboWare will plot a graph that will look similar to this. After viewing the data, open the File tab and click on Export Table Data to use in Log Tools. Then, in Log Tool, create a new database and click on Import Logger data to import data from HoboWare. Log Tools will then open this window. Select the logger file type and logger data file. Then click Import Check Channels. If there are multiple compressors, multiple channels can be selected. Once channels have been imported, the window will update. Close this window and select Date Type and click on Date Type as highlighted to create different date types for use in Airmaster. Once you click on date types, this window will appear. Label the different date types corresponding to the different days, then click on Create System Date Type Profiles. After creating date types, click on Copy Profiles to Clipboard and paste into an Excel sheet.
After preparing the data, open Airmaster and click on Company. When the new screen opens, click on the box highlighted and then input the facility information and then save the company profile. After saving the company profile, close the screen. Click on the Utility button. Create a new utility and input the utility company's information. After inputting the utility information, click on Rate Schedules to bring up the screen shown on the right side. Create a new rate schedule and then input the average energy and demand rates for the facility. After saving, close both screens. Click on the Facility tab. Create a new facility and also select the utility company's profile and rate schedule. Close the window. Click on the System tab. Once the System window has opened, input System Info and then click on the Date Types tab. In the Date Types tab, input the different date types and total number of days for each date type. Close this window. Open the Compressor window. In this window, import your compressor information based on nameplate or kg data. Be sure to include the compressor size, control strategy, full load operating pressure, and rated capacity at full load operating pressure. Click on Profile to enter the different date types. In the System Profile, turn on the compressor by clicking on the highlighted area for each hour. During the day, after the compressor has been turned on for the day, copy the voltage and amperage data from the Excel datasheet created earlier. Repeat this procedure for each date types. After the date types have been entered, Airmaster will calculate the current energy usage. This can be viewed by clicking on the Totals tab. After all the compressor information has been entered, savings from energy improvement recommendations can be determined by clicking on efficiency measures. Before calculating the energy savings, a sanity check needs to be performed because Airmaster determines energy savings based on the airflows created from power input. To calculate the sanity check, the system pressure is reduced by 0.1 psi and should show an energy savings reduction of less than 1%. After completing the sanity check, efficiency measures can be determined. The main two recommendations is to reduce system pressure and reduce air leaks. Reduce the system pressure to the lowest possible level. A considerable amount of energy can be saved in the compressed air system when it is maintained at the lowest allowable operating pressure. For systems operating in the nominal 100 psi range, for every 1 psi decrease in discharge pressure results in an approximate reduction of 1% of energy consumption. It is difficult to determine the lowest allowable operating pressure, but by reducing the discharge pressure in 1 to 2 psi increments, checking each time for proper equipment performance, the lowest permissible operating pressure can be reached. Here we show how to calculate reducing pressure for our facility by 10 psi with the energy savings shown on the far right side. Repairing the leaks in the compressed air system by replacing the leaking fittings, valves, and other components. A regular check of the compressed air system components will detect leaks before they become severe enough to adversely impact electricity cost and/or cause mechanical problems. Leaks can account for approximately 20% or more of the compressor's flow output in an unmaintained system, and for a well-maintained system, leaks can account for 10% of the airflow. Repairing air leaks will reduce energy usage and costs associated with operating the air compressors. We quantify the leak load by looking at the power data when the compressor is on during non-production air hours, and then using the corresponding airflow from Airmaster. The majority of the airflow during non-production hours is servicing leaks. We determined for this facility that 25 CFM is going to servicing leaks, and the facility is capable of reducing the leaks by 50%. The savings from reducing the leak load is shown in the far right figure.
We have shown you how our IAC analyzes air compressors with Airmaster. Thank you for watching.